Hello everyone. This week in Robotics Lab 1, we will go through the basics of rapid programming language. The rapid programming language is the programming language developed by ABB for their robots. So we will see what its structure is like, and we will learn about the basics of rapid programming language, and then we will use the test pendant to write the program using rapid programming language and move the robot. So let's start. Okay, at first let's go through some of the safety instructions. These are the instructions that we already went through last time, but before starting the lab, for now you are in your home, but whenever you come to the lab, you have to be careful about the safety instructions. Okay, now let's start with the theory of rapid programming language. So rapid programming language is the language that is used to control the ABB industrial robot arms. So let's go through some of the basics of it. So one of the most basic thing in rapid language is instructions. So the instructions are the set of commands that are given to the robot to do something. So let's say we want to move the robot from one point to another point. Then we have to give an instruction. So the instruction will have two parts. First part is the name of the instruction, and second part will be the arguments. So there can be multiple number of arguments in or instruction. So for example, you can see here there is a instruction called reset and DO5. So reset is the instruction and DO5 is the argument sent to this instruction. So what does this do is this will reset the value of the instruction. Okay, and after the instructions there is a concept of routines. So routines, you can say like functions, but it is quite bigger than functions. You can say this as subprogram. So in rapid there are three types of routines. First are procedures, second is function, and third is trap routines. So what is procedure? So procedure is like a subprogram. So if you need to do a certain task repeatedly, we will just create a procedure for that and then just call the procedure. For example, let's say our robot will change its end effector by itself. So at one point it will use the end effector with vacuum gripper, and in the next point it will use the end effector with welding tool. So we can write a procedure to load the end effector by itself. So we can just call the procedure from the main program. And second type of routine is function. So function is very similar to the function that we have learned in C programming language. So it is the program that has some return value. And the third type of routine is trap routine. So trap routine is also a kind of sub program, but it is different in a sense that it works with interrupts. So interrupts is a command or a signal that is sent to the robot. Okay, let's say if something is finished and we want our robot to do a certain task, so then there will be an interrupt signal to the robot. So for example, the part that our robot needs to pick up has arrived to its destination. So that means now our robot has to go and pick up that part and put it somewhere. So whenever a part arrives to the destination, then there is a interrupt signal. So the interrupt signal will tell the robot that okay, the part has arrived here, so you can do your work. So after that a trap routine is called. So after getting the interrupt signal, the trap routine is called, and the trap routine is like a sub program. So let's say the sub program will pick up that part and put it where it is meant to be. And one thing to note here is a trap routine can only be executed by interrupt. We cannot execute the trap routine using our main program. Okay, now the third thing we need to know is the data in Rapid. So we already know what a data is. Data is the information that is stored somewhere. So basically in robotics, or let's say in the industrial robot, we need to store data like last week we did TCP, right? So we can store the data about the TCP. So that is one kind of data, and then there can be other numerical data and various other kind of data, but we will discuss about the types of data in Rapid. So there are three kinds of data. First one is constants. So constants is just a static value that can be only assigned while we start the program. So basically you can compare this with exactly similar to the constants in C programming language. So it can only be assigned with new value manually. And second type is variable. Variable is also now again similar to what we learned in C. So variable is the data type where data which can change according to the execution of the program. So program can assign the value to the variable. And the third type of data here is persistence. So what is a persistence is like, let's say we are running a program in Rapid. So while running a program, there are many data that are being changed and stored in some variables. So if we want to save the data in a variable even after the program stops running, then we have to save them in persistent variables. So what does it do is like, okay, if something is saved in persistent variable, then even after the program is saved, it will still retain that variable. So for the next run, it will start from the previous data. It will not start from the initial value. So these are the types of data: variable, persistent, and constant. And these are the scope of the data: global, task, and local. So the global scope, global means every routines can access the data. It's same like global variable in C. And then there is a local variable. Local variable is local variable or local data are the data which can only be accessed within the procedure or within that function. And then there is a task data which is only accessible for that task. Okay, so this is the program structure for Rapid. So there are mainly two modules. First module is program module, and the second module is system module. So as the name suggests, system module will get all the information or run all the information or programs related to the system, and the program modules are the modules that we create. It can contain a single module can contain its own data or the global data, and then it can also contain multiple routines. And the flow of the program in Rapid is controlled by one of the program module called main, just similar to the C programming language. So main is the program that will control the flow of the program, and from the main, within the main program, we can execute several other modules. So to call other modules or other procedures, we will use the instruction proc call or procedure call. So you see, this is one example of a program in Rapid. So we can see this is the procedure main or main module. So this is the place where our control of the program it starts. So at first there is one instruction, and in second one you can see there is a pick pen procedure call. So what this will do is, when we execute this instruction, this will call the procedure called pick pen. Like I told you already, our program will have lots of sub programs. So those sub programs are written into procedures. So those procedures can run independently, or when the main program can call those procedures or those sub programs. So whenever our program runs, so they will execute the first instruction and the second procedure calls. When we call the second procedure call, our program pointer will move to this part, so this procedure, and it will execute these commands. And then after finishing this command, after it reaches the end of the procedure, then only it will move to the next command, and similarly it will follow. So this is about the program and how we can start a program in Rapid. So we will use the flex pendant. So for that part I will explain in the separate video. So let's skip for now and let's go to the joint and linear motion. So what is joint and linear motion? So the joint and linear motion is to explain one of the instruction of Rapid programming language. So the joint motion is obtained by the instruction MoveZ. So that means MoveZ will move our robot from one point to another point. So when we use this instruction MoveZ to move the robot from one point to another point, it is not necessary that our robot will move in a straight line. It will try to create a path on its own such that all the axes of the robots will move at the same time and reach to their destination at the same time. So it is not necessary that our robot will move in a straight line when we use MoveZ, but it is quite fast, and also it is quite good for our robot as well. So this is a typical instruction of MoveZ. So you can see this is an instruction. Let's say name of the instruction is MoveZ. You can see here, name of the instruction is MoveZ. It is followed by few arguments. So let's go through these arguments. So the first argument is the rope target. It's defined by the sign asterisk, or we can also name this point with some name. We will see in the practice session. So what this rope target is this rope target is the destination point that we want our robot to be in. So if we want to move from the initial position to certain position in the space, we will have to give the destination point as an argument called rope target, and next argument is speed. So MoveZ to this target with this speed. So the speed right now in this example is 1000. So 1000 is 1000 millimeter per second. And the third argument is zone. I will explain about zone in next part after some time. And the last argument here is the tool. So last week we added the tool. So after we add a tool or end effector to the robot, we can add the tool or we can add an instruction based on that tool. So how can we read this instruction? We can read this instruction as move the tool 0 to this position asterisk or star with speed 1000 millimeter per second and with zone data 50 millimeter. Okay, what is zone? So zone, it describes how close we want our robot to reach or for the destination. So for example, let's see this picture. Okay, there are 3 commands. So MoveL is to move in linear. I will explain about this next, but you can just imagine it as MovesA. Okay, so the first instruction here is move L to point 1 with speed 100 and the zone value is 10 with tool 0, and the next command is to move to P2 and the third one is to move to P3. So when we execute these 3 instructions, so our robot will move from point 1 to point 2. So whenever it reaches close to point 2 or whenever it reaches in the zone, so the zone here is defined by the value 10. So the value 10 here means there is a zone around that point of radius 10 millimeter. So whenever our robot reaches in that zone, our robot will now deviate to the other point that it has to go. So it will not reach to our destination exactly, but it will, whenever it is near to that, it can go to the other point. If we want our robot to reach to that point exactly, then we will change the value of zone to be 0, or we can set it as fine. We will see that in the next video when we use Robot Studio. So the next command here is MoveL. So MoveL is same as MovesA, but here L stands for linear. So that means when we use MoveL, our robot will move in a straight line to reach to that destination. So all the arguments are same for MoveL and MovesA. So MoveL, rope target with speed this, zone this, and which tool is tool 0. So now the third commonly used instruction is MoveC. So here MoveC stands for move circular. So if we want our robot to move in a circular fashion, then we will use MoveC. So the syntax for MoveC is, let's see, MoveC, robot target, and then everything else is okay, velocity, zone, tool, or work object. So the work object was optional with MoveL and MoveZ, and with this also it's optional, but we will define work object. We will learn about it next week. So for now, let's see how we can use MoveC. So when we want to move our robot in a circle, so the MoveC will help us to move our robot in semicircle. So if we want our robot to make a complete circle, then we have to execute MoveC 2 times. So what are the arguments in MoveC? So the first argument you can see in red color is the midpoint. So whenever we start the instruction MoveC, we are in one position. For now, let's say we were in this position here. Then we will define MoveC. We will define the midpoint and the end point for the semicircle. So the endpoint is shown in green, so it should be the second argument, and midpoint should be the first argument. So to read this instruction, we can read as, okay, moves the pen tool in circular position until the end following the midpoint with speed v and zone 10. So let's see here how here is the example of how we can draw a circle from here. So at first we will go to the point P1. So MoveL will take our robot to P1. So by robot I mean the end of the robot, the tip of the robot. Okay, so the tip of the robot will reach to point P1, and then we will execute MoveC. So you can see the parameters, the arguments that we have passed here is P2 as a center point and P3 is the end point. So that means our robot will now move from P1 to P3 through P2. So it will make a semicircle. So once it is in P3, we will again add one more instruction, MoveC P4. So from P3 to P4, and then it will reach to P1 at last. So this is how we can use MoveC to make a circle. We will see how we can do it in next video as well, but this is how we can write a instruction, or how we can read the instruction MoveC. So apart from these instructions, there is also one offset function that is very useful. So the use of offset function is, if we have a certain point in a space like P1 or P2, then we can mention the new point based on the first point P1. We will just say, okay, from this point move certain millimeter in X direction, certain in Y, and certain in Z. So you see the offset function is shown by red color here. So offset function has 4 parameters. First argument is P1 or any point from which we want to offset, followed by X, Y, and Z. So we have to define, okay, for example, if we want to move our robot from P1 to 10 millimeter in Z axis, then we have to say P1, 0, 0, 10. So that now it will move our robot to the new position. So here's an example how we can draw a perfect circle using offset function. So we already know to draw a circle we will use MoveC, but let's see, we will bring our robot to this point at first at P start. So we have used the instruction MoveL P start. So this will bring our robot to P start, and from P start we have to mention the midpoint and the endpoint for the semicircle. So let's see how we can use offset function here. So in this command here, the second one, MoveC offset from P start 100 in X direction, negative 100 in X direction, and negative 100 in Y direction. That means we are defining the point based on the starting point. So so we can see this offset, the first offset function will bring our robot, or let's say the first offset function will return this point, and the second offset function will return this point. So our robot will make a semicircle until this point, and again we will add another instruction to make another semicircle. So this is how we can use we can create a perfect circle using the offset function. So next thing is about modifying the position. To modify the position, I will explain this in our next video with teach pendant. And if you want to add some comments to the program in Rapid, we will use the exclamation mark. So you can see here in the line number 9, we have exclamation main routine. This is the comment that okay, this is the main routine. So this much for the basics of Rapid. So in the next video we will see everything that we learned in practice using Robot Studio.